Hello, so continuing on this weekly contest 340, this week's contest, the second problem, sum of distances. So what this problem says, we get an array of numbers and called nums, and we want to return an array, a new array, and this array we can fill it with the following conditions. So array at position I would be the sum of the absolute value of the difference between I minus j. So for index I in the new array is going to be the sum of the absolute difference of I minus j, where j is all the other numbers that are equal to this number in other indices, right? So the indices need to be different and the values equal, and we want to take all of them, take the sum of the absolute difference and set that in the array I position. Now, if the number doesn't have any equal value in the rest of the array, then we want to just set it to 0 in the array, and then we return the final array, okay? So let's take a look at this example here. So this array has, the first index has these two that are equal, right? And so has index 0, 1, 2, index 2 which is equal. So for that index, we do 0 minus 2, right? The index of I is 0, so this is 2. So 0 minus 2, and then the other index is 3, so 0 minus 3, so the sum is 5, okay? 3 doesn't have any equivalent value, so equal value, so we return 0. This one here has these two that are of the same value, so we take the sum of the differences, and so it's I equal to 1. What are the other the other indices? 0 and 0 and 3, and so just we take the sum there, and that's 3. And then for that's for this one, and then for this one we take this one and this one, and so 0, 1, 2, 3. So the index here is 3. 3 minus 2, that's 1, and 3 minus 0, so that's 3. So the sum is 4. And then 2 doesn't have any other equal value, so we put 0. So that's sort of the idea. Now the numbers can be up to 10 to the power of 5 numbers. So that tells you we can't use an O(n) squared algorithm. So we need to find a better solution, either O(n) or O(n) log n. Okay, so let's see how we can handle this. So let's first suppose, just to make this to be able to work with this a little bit, let's suppose for some index I, let's suppose we have j1 that has a value equal to it. So let's suppose we have, let's call this array. Let's suppose AI is equal to A of j minus j1, and let's suppose it's equal to also j2, just to have something to play with. And so what this tells us is that what should be the value for array of I? Maybe it's easier to keep this called nums. Here and here. So this is nums, this is nums, and this is nums, and this is nums. So what would be the value for array I? So it tells us that it needs to be the absolute difference for I minus j1 plus I minus j2. Okay? And so here, it's really hard to sort of, we have two i's here, but it's hard to get them together because we don't know if j1 is smaller than I or j2 is smaller or bigger than I, right? And so let's do it case by case, right? So case 1, let's suppose, right? So let's suppose I is bigger than both. So if I is bigger than j1 and j2, then what does this mean? Well, that means that the absolute difference plus the absolute difference, because I is bigger, we can just get rid of the absolute difference, right? So that would be I minus j1 plus I minus j2. So this would be 2 multiplied by I, right? Minus the sum of the two, right? The sum of j1 plus j2. Okay. Now let's take case 2 and suppose that, what if I is smaller than both? I know there is a case maybe I is smaller than j1 but bigger than j2, but we can write our solution in a way that only these two cases apply. I will explain in a moment how we can do that. But if I is smaller than both, then in that case, we know that if we take the absolute difference, then what is this? This is going to be just equal to j1 minus I, because we take the absolute difference. Then this one, I is smaller, this one is bigger. That means when we take the absolute difference, we'll actually get this. And similarly here, when we take the absolute difference, we'll actually get g2 minus I. So this would be g1 minus I plus g2 minus I, right? So this would be just j1 plus j2 minus 2 multiplied by I, right? Okay. And so you can see this. Why did I write it this way? Well, because to avoid having to write two loops, right, each time to get all the indices that are different than I, if we do it in a way where we have two cases, I bigger and I smaller, we can actually just do two loops, one left to right, basically, which means when we get to I here, all those that we've seen before are smaller than I, right? So I is bigger, so we will be in this case. And then we can do another loop from right to left, where when we get to I here, that means all of those before it were bigger, which means I is smaller, so we are in this case, right? And actually, if we take a look at this example here, let's say for this one, well, for this one, it's just the ones that are equal to it before it, the sum that we get from those, and then the sum that we get from those after it, right? Actually, this one is a better example. So what does the array of 2, what is this one? Well, it's just the sum of the differences we get from equal values to the left, plus those that we get from the equal values to the right. In this specific case, it would be the difference that we get from this one and the difference that we get from this one, right? And so in this problem, since with those two cases we'll be able to use this formula, let's just calculate them separately, right? Let's for each index calculate the sum of the differences we get from its left side and the sum we get from its right side, and just add them together in the array value. And so that's the main idea here. Okay, so now the question becomes, for each case, for the left and the right, how do we easily calculate these? Well, we can just use a map, right? So we can just use two maps. One is the map for this sum here, for all of those that we've seen before. And then one is for how many we've seen, right? So we just need to know the sum and how many, because this two here is because we have two indices. This two here is because we have two indices. If we generalize this, and let's say we had 3 indices before, right, then it would be 3 multiplied by I minus j1 plus j2 plus j3, and the same thing applies here, right? And so in that case, we just need two maps. I will call one the seen sum, because it will be this one, and the other one I will call it count, because it would be count how many, right? And so if we take our original array, here, let's just delete these. So if we take this array and apply this algorithm to it, what would it look like? So of course we need to fill an array right here, and we will first go from left to right. We will go with seen sum map, and then we will have another one which is the count map. So count will count basically how many occurrences of each number. And so when we get here first, this is first left to right pass. And so 1, we haven't seen any of it yet in seen sum, and we haven't seen any of it yet in count. So nothing to do here. But we need to record that we've seen it. So we say we've seen 1, right? So let's call 1 here. What's the index? So we want to put the index, right? Because we add actually the indices here. So this basically let me clarify this. So the key would be the value, right? And then the value would be a list of indices that have that value, because that's what we are asked to do. J1 and J2 are the indices that have the same value as I. And then the count, the key would be the value, and then the value would be how many times we've seen it. We've seen it so far. So the number of occurrences, right? And so here we will say seen, what's the index? The index is 0. And then the count is for the value 1. We've seen it once. And now when we proceed here, so now this so far has 0, right? Because it was 0 minus 0. And so we go to 3 here. So actually, let me just clarify what will it be. So going for this formula, right, from left to right, remember from left to right, I is bigger, so we use this formula. So for left to right, we use this formula, which is basically just count. So what is 2 here? 2 is just the count of the occurrences of the number. So let's call it nums at I, multiplied by the index, which is I, okay, minus the sum of those that we've seen so far. So seen sum for that number, which is I, the value. So this is basically just a translation when we are going from left to right. And then when we are going from right to left, we will use this formula, okay? And so here, for 3, we haven't seen it yet, so both are zeros. 0 minus 0, that's just 0, so put 0. And then for this one, now that's interesting because we've seen it before. So how many, what's the count? The count of it is just 1. So 1 multiplied by I, which is, I is the index. So 1 multiplied by 2 minus the seen sum. How many in the seen sum? Well, it's 0, right? So minus 0, so that will be 2 here. Okay? And then we will go here. First, before going, we need to set up the seen sum. So now we have index 2. So this 0 plus 2, that's 2. Because it's the sum, remember? And then here, the count, we need to increment by 1. So it's 2 now. And then we'll proceed to this one. Okay, so 3, what do we need to get? Well, it needs to be the count, which is 2, multiplied by I, which is, in this case, 3, minus the seen sum, which is 2. So it's 6 minus 2, which is 4. So here we have 4. And 2, since we don't have it here, is 0 minus 0, so it's a 0. Okay, so this, what the left right tells us we have. We are going to do a similar pass for right to left. So we will reset our seen sum and count because now we are doing another traversal. And so let's just copy our array here. So our nums is 1, 3, 1, 1, 2. And we will use the array because remember we do the left and then we add up the right, so we'll still have the array to update, and the array is going to be just what we had for left to right, and then we will update it to sorry about this, so 0 2 4 0. Okay, and now we will have seen sum, which is initially empty. Okay, and then we would have the count, which initially is empty as well. And then we'll use the formula for right to left, because in this case, I would be smaller than the before elements, the before indices. So we copy this out, and this is what we'll use here. Okay, and now let's just delete. Okay, cool. Okay, so now we go right to left, so like this. So we start out here. Let's put the indices 2, 3, 4. Okay, so for 2, we haven't seen it yet, and so it's still 0 because it's 0 on both, and so we keep 0. 0 plus 0 is just 0. And now we add that we've seen 2, and so we say the value 2, we've seen it at index 4. And then count of 2, just 1. And then we go here, 1. Have we seen 1 yet? No, it's 0, 0 in both. So 4 plus 0 is just 4. And now we add that we've seen 1 at index 3. Okay, and then we add that we've seen 1 once. And then we go here and we check the, now we've seen 1 before, right? And so it's going to be the sum of what we've seen. So this is just seen sum minus, so seen sum at index I, of course, for the value minus count of that value multiplied by I. Okay, and so this would be, seen sum would be, in this case for 1 it's 3 minus the count, which is 1, multiplied by I, which is in this case 2. So it's 3 minus 2, which is 1. And so we want to add 1 to this value here, so it becomes 3. And then we want to update. So now this is the sum of the indices. So what's the index? 3 plus 2. This becomes 5. And then what's the, we need to increment that we've seen 1 more time. So this becomes 2. And then we move here to this 3. Now 3 is not here, so it's 0 minus 0, so we have 0 still. 0 plus 0 is just 0. And then we progress here. We say, of course, that we've seen 3 once at index 1. And then here we've seen 3 once. We move to 1. Now 1 is at index 0, and we already have 1. And so we say seen sum of 1, which is 5, minus the count of the numbers at 1, for 1, which are 2, and we multiplied by I, which is 0, and so that's 5 minus 2 multiplied by 0, so 5 minus 0 is 5, and so we put 0 plus 5 here, we put 5. And this gives us 50340, which is exactly what we have in Leetcode solution. And this should work fine, okay? So you can see here, we just took it from 2 indices, and we got a solution, and then we generalized that solution, and then we applied it from left to right and then right to left. In this solution, because we just do one pass that is O(n) pass left to right, and then another pass that is O(n) right to left, it's O(n) time. Okay. Now in terms of space, we are using these two maps, the seen sum and the count, so it's O(n) space. Because at most it would be O(n) each. Yeah, so that's pretty much it. Now let's code this solution and make sure it passes. Okay, so let's code this solution up. So we said first we need to do a left to right pass and then a right to left pass. So the first left to right, we have a seen sum, which is just going to be a map with, we are just going to default to int, which basically means that for values that don't exist yet, it would be 0, which makes sense, right? We haven't added anything, so it's 0. And then we need another one for count. Feel free to use either a collection, same thing, or you could also use a counter, both work. And now we also need to define the array that we are going to return. So it's just going to be 0 for each place first. And then we will fill it up as we go. So n is just the length of the array. And then what do we want to do next? So what we want to do next is we want to do a left to right pass. Okay, so left to right pass first, and then after that we do a right to left pass. Similar to what we saw in the overview. So for left to right, we just go through the numbers. And for each one of them, what do we want to add? Just the formula that we saw, which was, for example, for 2 indices, it was 2i minus j1 plus j2, which if we generalize it, is just going to be the count of the similar values, the same values that we've seen before, right? Multiplied by I minus the sum of the indices that we've seen before. So this is going to be just seen sum for that same number, okay? And so that's exactly what we are going to do. So we are just going to use, if the element is not yet seen, we will have 0 for this one, and then we'll have 0 for the count, so overall it would be 0. So we'll be adding 0, which doesn't change anything, so it works. So here what we are going to do then is just this formula, which is the count of what we've seen before multiplied by I, minus the sum of the indices that we've seen before. So this is sum of indices seen before, okay? And this is count indices of the number of the values seen before, and this is the count of val seen before, right? And so now we want to add it for the next elements. So we say seen of nums at I. What do we want to add? The index, because this is the sum of the indices. So we want to add the index. And then the count is going to be just 1, because we just record that we've seen it. And that's pretty much it. And now we want to, once we do the left to right, we want to reinitialize those two for the right to left pass. Okay, and so for the right to left, we just go from the end all the way to 0. In Python, we can write it like that. And then we do the same thing. We just record, except the formula here is different, because remember, the formula here needs to be in the two pair case, the pair of just two equal elements. What we've did is, because I is going to be smaller, right? So the absolute difference sum is actually going to be J1 plus J2. Go back to the overview if you don't completely understand this, minus 2i. So if we generalize this, it's just going to be the number of the sum of the indices. So that's going to be nums at I. So we just flip it, right? Minus the count multiplied by I. Okay. And then at the end, we can just return the array. So if we run this, looks like we have, yeah, this is just seen sum. Same thing here. This should be called seen sum. And let's submit. And this passes our test cases, right? Yeah, so that's pretty much it for this problem. Very simple once you do 2 passes. Please like and subscribe, and see you on the next one. Bye.